All right, ladies and gentlemen, here's your 10.4 lesson video for measuring arcs and angles. So some important concepts that we first need to talk about here is going to be what an arc is. And an arc is going to be a portion of your circumference of a circle. Remember, the circumference is that circle around. You're going to have a central angle. In this, your central angle is one that has a vertex at the center. So that center letter will be where the vertex, it will be the center of the circle. And the sides of this angle are going to be the radii of the circle. Next, you have what's called a minor arc. A minor arc is going to be an arc that we talked about in the first bullet point, but its measure is going to be less than 180 degrees, and it is named by its endpoints. One thing I want you to note on here is it is named with only 2 letters. So when you see an arc named with 2 letters, you know it's going to be less than 180 degrees. It'll be a minor arc. Now your major arc is going to be the opposite. It's going to be one that measures more than 180 degrees. And it's going to be named by its endpoints and one other point on the arc. Okay? So this one, your major arc, is going to be named with 3 letters. So you have to grab the 2 endpoints and then some point between those 2 endpoints. Congruent arcs are going to have the same measure, just like we know that's what congruence means. It's going to have the same measure in the same or congruent circles. Arcs can be measured by their corresponding central angles. Okay, so your measure of your central angle is equal to the measure of the arc, and we're going to go ahead and we're going to discuss that here in a little bit. Okay, so down here below on our picture, example number 1, we're going to name the following. The first thing we do is we're going to name the central angle. That central angle is going to be right here. So we're going to name it with the endpoint, the vertex, and then the other endpoint. So this would be angle L-E-Y. L-E-Y. A minor arc, there are only two arcs here. The minor arc, remembering that we have to name it with only 2 letters, is going to be right here. Go ahead and switch colors for you guys. Right here is going to be our minor arc. And you can either name it arc LY or arc YL, whichever one you want to. Doesn't matter which order those go in. Then we have our major arc, which is going to go the other direction. It's going to be over 180 degrees, over half the circle. So this is going to have to be named with 3 letters as discussed. The middle letter has to be this U, okay? So you can either say arc L-U-Y or arc Y-U-L. So I'll just call it arc L-U-Y. So let's talk about our first theorem here. Our first theorem is that the sum of the measures of the central angles of a circle with no interior points in common is 360 degrees. All that means is all the way around the circle is 360 degrees. Okay? So what we're going to be looking at here is your central angle and the arc it opens up to are going to be congruent. So we're going to find the measure of each one of these in example 2. So the first one, we're going to look at the measure of angle. Okay, look at that angle piece there, PCM. So we're looking at P to C to M. Well, it's already written there for us, 110 degrees. Now we're going to look at arc PM. Arc PM is only 2 letters, so it's going to be less than half the circle, a minor arc right there. Well, the arc is going to be the exact same measurement as the central angle, as it says up here. The measure of the central angle is the same as the measure of the arc. So if the central angle is 110, the arc is going to be 110 as well. So we'll put here same as central angle. Next, we want the measurement of arc PNM. So we know it's going to be a larger arc here. We've got this guy over here. So all we have to do is take that 360 that the whole circle is around and subtract the 110 from arc PM, and we're going to come up with 250 degrees. Okay? Now it's asking about arc PM. What type of arc is this and how do we know? We know it's going to be, as we discussed earlier, This is going to be a minor arc. We know because it measures less than 180 degrees. As we saw up here, it was only 110, so it's less than 180 degrees. Okay, if you need to pause it, please do. We're going to go ahead and move on to the next page. So the other kind of arc-like thing that we're going to be talking about is now going to be the semicircle. A semicircle is going to be between the minor arc and the major arc, and it is going to have a measure of exactly 180 degrees. It's going to be half of that circle. Okay, it will be named just like a major arc with its endpoints and another point on the arc. Okay, so again, we're going to have 3 letters. I think my purple pen's dying. I think it's time to retire him. So our example 3, we're going to look at a couple things. We are going to see and label what we need to label. Okay, always make sure we're labeling. In circle E, the measurement of angle AEN is going to be 18 degrees. JN is the diameter. The diameter is what creates 2 semicircles. So you have semicircle on both sides. And the measurement of angle JES is going to be 90 degrees. Okay, I'm going to put the marking as well as I'm going to write in 90 degrees. So we want to find first the measurement of arc AN. Well, as we discussed, the central angle and its corresponding arc are going to have the exact same measurement, so we have 18 degrees. Next, we want to look at the measurement of angle JA. So if we find J and we go over here to A. All right, so here's JA. It's still going to be a minor arc because it's less than half that circle. Okay, so since JN right here is a diameter, so we'll put arc JN is diameter. We'll say therefore arc, sorry, I should say not JN, JAN. Sorry about that. I do have to have 3 letters, so since segment JN is a diameter. Therefore, arc JAN, arc JAN, equals 180 degrees because it's a semicircle. I know it's 2 words. Ran out of space. So all we have to do is we have to take that 180 from the full semicircle, subtract that 18, and we'll have what's left over for arc JA. So 180 minus 18, we're going to get 162 degrees. So in this case, you're going to, in this section, you're going to have to start looking at different angles and subtracting some things. The last one we're going to look at here is going to be arc JAS. You have to go in that order. So you start at J. We need to get to S, but we have to go through A. So we're going to be going from J through A over to S. So what I want you to see here is we're covering almost all of the circle of 360 except for that 90 degrees. So we're just leaving that 90 degrees out. So we just take 360, subtract that 90 degrees that's right here because we're not covering this arc, and we're going to wind up with 270 degrees. Okay. Now we're going to name a few things. We are looking at ray FD right here is going to be a tangent. That's going to come in handy later to circle O, and then we're going to go ahead and find all of these measurements. Now, one thing I personally like to do is I like to come over and say, okay, well, I already have my central angle 45 here, so I know this arc is going to be 45 degrees. This central angle is 85, so I know this arc right here is going to be 85 degrees. And that's all I can do. Well, here's 90, right? So then I've got a 90-degree arc over here because these are all the central angles. So now we can look through and start saying, okay, what do they want us to find? All right. Measurement of angle DOF. So we have D to O to F, all the way over here. So we want this guy right here. So what we could take a look at here is that we're actually going to use the tangent line. We know that tangent and a radius will form 90-degree angle. So here we're just going to focus on this triangle FOD. Well, if this is 90 degrees, that means your two acute angles add to 90. So all we have to do is 90 minus the 38, and then we'll have this angle right here that we need, which is 52 degrees. So I can write it right here, 52 degrees, which also tells me, hey, my corresponding arc is going to be 52 degrees as well. Now we want to find the measurement of angle EOA. So we go EOA. So what happens here is we kind of have a lot to do. We need to take all of these angles, the 52, 85, 90, and the 45, and subtract them from the whole 360 to find out what's left over. So over here we can look at it algebraically and say, okay, EOA is going to be X plus the 45 plus the 90 plus my 85 plus my 52, all equal to 360 degrees. Please pause it and solve this and find out what X is, combining your like terms and subtracting. Now that you've paused and figured it on your own, combining like terms gave us 272, all equal to 360. We'll subtract that 272, and we're going to find out that X is going to equal 88. So this degree measurement here will be 88, and so will the arc out here. So we have 88 degrees. Next, we want to find measurement of arc AB. So we come over here to AB. Luckily, since we already labeled it, because with our central angle, we can just go ahead and say, okay, 45 degrees, done. Now we're going to move on to arc AD. If you look at AD, you need to decide which way to go. Well, there are only two letters. If I go this way, I'm going over 180 degrees. So I need to go this way, straight to AD. Well, arc AD is just going to include that 88 plus that 52. So it's just a matter of adding and subtracting with this guy. And we're going to wind up with 140 degrees. We want to remember that this is a minor arc because it only has two letters. Now let's take a look at arc AC. So again, we're not going around this way because that's going to be a major arc. We need to go around this way. So arc AC is also going to be a minor arc because of the two letters. And all we need to do is add that 45 and that 90. 45 here and the 90 here. So 45 plus 90 will give us 135 degrees. Now we're going to take a look at, we want arc BC. Well, again, we've already labeled our arcs as the same as a corresponding or matching central angle, so 90 degrees, easy enough. That's why I like to label my arcs with my central angles. Now we're looking for the measurement of arc ADC. What we need to notice on this one is this is going to be it's either going to be a semicircle or a major arc because of the three letters. Okay, so let's take a look. A to D to C. It's not a semicircle, so we're going to have a major arc. And what we need to do is just add everything together. A to D to C. So we need to add the 88 plus the 52 plus that 85. Go ahead and add those together and get that yourself after you pause. We're going to find out that this is 225 degrees. Verifying that we have over 180 degrees, it is a major arc. All right, let's look at the measurement of angle ACD. So we're going A, we can't go this way to C and then back to D. We have to go around this way, A to C to D. So again, we have a major arc. So now going A, C to D, we need to add up all of these. We got 45 plus that 90 plus that 85. Add those together, we're going to get 220 degrees. Next, we want the measurement of arc ED. Well, we found that in the central, its corresponding central angle EOD earlier, so we know that it's 52 degrees. That one we just have to read, no adding, no subtracting. And the great thing that's going to happen next is the exact same thing. We're looking for arc AE, two letters, minor arc. AE, it's right there. We found that the central angle earlier, 88 degrees. Okay. So I just realized it kind of May have gone off the screen there for a moment. All right, last page, ladies and gentlemen. Very last page. Let's get this over and done with. Now we have some algebra to do. Okay, so this one you're going to want to pause and solve the algebra on your own once I show you how to set this up and everything. What we need to notice is that the first things first, so I'm going to come down here. We notice that we have all of the arcs, but they're all variables. So what we need to do is we need to make sure that we add them all together to equal 360 degrees. So you can start anywhere. Here's my, make sure we're on the screen. Yep. 3x, move it up so I have room, because I know I'm going to need a lot of room on this one. 3x plus 15 plus that x, I'm just going clockwise, plus 4x plus 2x plus 15. All of these are going to add to equal 360 degrees. Please pause this, combine your like terms, and solve for x on your own, please. Please, 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 please. All right? So now that you've done that, like I asked, because you're so awesome, we're going to go combine our like terms. We have a 3x here. I have a plus 1x here. I have a plus 4x's here, plus 2x's, and that's it. So we add all of those together, we're going to end up with 10x. Now for our constants, I have a plus 15 and a plus 15, and that's it. We shall be able to do that one in our head. We have a plus 30 equals 360 degrees. So, finish solving for x. Subtract that 30. We're going to wind up with 10x is equal to 330. Divide by 10. X is going to equal 33. Now we're going to need this special 33 right here to help us with A, B, C, and D. Okay? So first things first, let's take a look at the measurement of angle AOB right here. AOB. That's just x. Well, x was 33, so that one's easy enough. 33 degrees. Got it. Next, we're going to take a look at the measurement of angle BOC. So we go B to O to C. So we have 4x. We're going to take that 4. We're going to plug in what x was, which was that 33. And we're going to get 132. Next on the list, measurement of angle, we're just going in order. COD was 2x plus 15. So 2, substitute in for x, plus 15. And we're going to wind up with 81 degrees. And lastly, we're going to have the measurement of angle AOD. So we have 3x plus 15, substitute in. And we're going to wind up with 114 degrees. And if you go add all four of these together, you should get 360 degrees. Okay? So there's working with angles, working with arcs, and with our algebra. Now this last section, example 6, I really, really want you to try your hardest. Pause the video, and if we were doing the flipped classroom, I would have you do all of these, every single one of them. Okay? It's going to go exactly like what we did on this section right here. Okay, you need to take a look. But the good news is we don't have that triangle we have to deal with. Okay, so this one might be a little bit easier. So pause it, please, and follow what we did on the last one. And then resume and check your answers. We do want to know what kind of arc it is as well. Okay, so now that you're done doing it on your own, we're going to go ahead and say, all right, I'm going to label here my central angle. Here's 25 degrees, so I know my arc is 25 degrees. Here I've got 90. So here I've got a 90, corresponding arc. This central angle is 38 degrees, so the corresponding arc is 38. Here we have 87, so here we have 87 degrees. So that's all we have right now, and let's just go ahead and take a look at what we have. The first things first, we want to find the measure of arc PN. So we're going to look over here at PN. Oh, score, we've already got it, 90 degrees. And because it is under 180 degrees, this is going to be a minor arc. I'm just going to abbreviate it min arc. Now let's take a look at ZQP, measurement of ZQP. It's either going to be a semicircle or a major arc. So we're going to go from Z over to Q over to P. It told us up here that PZ is the diameter. So when we're going from Z to Q to P, we're talking about that diameter creating a semicircle. So this is 180 degrees, and this will be a semicircle because we go from one of the diameter to the other. Measurement angle RZ. Well, I can already tell what kind of arc it is with the number of letters, right? So here we have RZ. I know it's going to be a minor arc, but we don't have a measurement yet. So what we're going to do here is we're going to take this semicircle, okay, that's ZQP. We've got two of them. We know that all three of these are going to have to add to 180 degrees. So we can take that unknown plus the 87 plus the 38, okay, because right now this is X, we don't know what it is, all equal to 180 degrees. When you go through and you solve this, I actually did it differently in my notes, but this would be 125, X plus 125 equals 180. Subtract that 125. Okay, I'll go ahead and draw an arrow so we know what we're looking at. And then your unknown X is going to come out to equal 55 degrees. So here we have 55 degrees. So with central angles and your corresponding arcs, this is the basis of what you're doing, guys. It's pretty simple. It's just kind of basic. Next, let's look at arc ZMP. So we're going to go from Z, and we need to get to P, so I got to go through M first. We're looking at this arc right here. Again, if you look, we're going from Z to P. Well, those were our points for our diameter. So that's going to equal 180 degrees, being a semicircle again. All right, arc RM. Well, I know it's a minor arc, 2 letters. So we're going to look at here, RM. Well, now we have another problem because we don't have ZM. So we'll kind of draw a line down here, do some math. We know that RZ plus ZM, those two together, are going to equal what we want. So we can take a look at here. How do we want to do this? Try to remember in the notes.